Welcome back. In this video, we are going to solve problem 10-92 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is the shaft consists of solid segment AB and a hollow segment BC, which are rigidly joined by the coupling at B. If the shaft is made from A36 steel, determine the maximum torque T that can be applied according to maximum shear stress theory. Use a factor of safety of 1.5 against yielding. So you can see this is segment of shaft AB and this is of segment of shaft BC that are coupled together using a coupling at B, and there is a torque T applied to this coupled shaft. So you have to find this torque T by using the maximum shear stress theory, and you have to take factor of safety of 1.5 against yielding. Let's start with the solution. As you can see, both the shaft are under pure tension, so I can write that this is a case of pure shear because there is no other load. So this pure shear will cause torsion, and due to this torsion the shear stress will be generated in each shaft. So the shear stress is contributed by torsion. As we have two segments, one is this is shaft AB is solid segment and shaft BC is hollow segment. So we can write that maximum shear stress in hollow segment will be equal to T into C of hollow segment divided by J of hollow segment, and maximum shear stress that will be generated in solid shaft will be equal to T into C of solid divided by J, where C is radius and J is the polar moment of inertia. So Js is polar moment of inertia for solid segment, and Jh is the polar moment of inertia for hollow segment. So what we will do is that we will find them. Again, you can see that Ch for hollow segment, you can see the hollow segment is this one. So the outer diameter is 100. So Ch will be equal to 100 divided by 2, and that will be equal to 50 millimeter. So Ch will be equal to 50 millimeter. I will write it, and 50 millimeter is equal to 0.05 meter. Okay, now for Jh, polar moment of inertia of hollow shaft, that we can write formula for this is pi by 2 Ch power 4 minus Ch inner power 4. Okay, so pi by 2, I will put the value pi by 2 C inner Ch, which is the outer radius, that is 50, and that is 0.05 power 4 minus C inner. So inner diameter is given as 80, so that will be radius C inner will be equal to 40, and 40 in meter is 0.04 power 4. And you can calculate that. I will calculate. So this will be equal to 0.05 power 4 minus 0.04 power 4 multiply by pi and divide by 2 will give you this value, which I can see. You can see that it is 0.00000579, and unit will be meter power 4. And we can write this Jh is equal to 5.79 into 10 raised to power minus 6 meter power 4. Okay, now here we will find Js. So solid, for solid shaft, I will check it that radius is diameter is given as 80. So Cs will be equal to 80 divided by 2, that will be equal to 40 millimeter. So I can write Js is equal to 40 millimeter, and in meter Js, sorry, not Js, it is Cs. 40 millimeter. Let me correct it, because C is the radius of solid shaft. So CS will be equal to 0.04 meter, and JS will be equal to pi by 2 CS power 4. So put the value pi by 2 multiply by 0.04 power 4 will give us JS, and I will calculate it here. 0.04 power 4 multiply by pi divide by 2 will give you 0.000040 meter, or we can also write JS is 4.02 into 10 raised to power minus 6 meter power 4. Now you have each and every value. So what we are going to do is that we will find maximum shear stress for hollow segment, that is T. T is not known, which we are going to find, multiply by CH. So CH is 0.05 divide by J, and J is 5.79 into 10 raised to power minus 6. So what we are going to do is that 0.05 divide by this value 0.00000579, and you can see we will have this 8635.5 times T. Okay, so maximum shear stress in hollow segment or hollow shaft is 8635.5 times T. Now we will find this shear stress in solid segment. So shear stress in maximum shear stress in solid segment is T into C. So T is there. C is 0.04 divided by J, which is 4.02 into 10 raised to power minus 6. And what we will calculate its value. So again you can see 0.04 divided by 4.02 into 10 power minus 6. Okay, and that will give us 9950.2 times T. This is T. Okay, now we have two shear stresses, one for the maximum shear stress in hollow shaft and one is maximum shear stress for solid shaft. So by comparison we can see that by comparison the points on the point or the shaft of solid section will experience larger shear stress. So what we are going to do is that we will select this maximum shear stress in solid segments. Okay, so we will take maximum shear stress in solid segment for calculating this torque value. Clear? Okay, now we have this maximum shear stress here. You can see this is under pure shear stress. So sigma x is equal to sigma y is equal to 0, and we have only shear stress of xy, which is 9950.2 times T. So if I draw the state of stress on the element, so it will be purely like this. This will be the state of stress, this one, and this shear stress of xy is 9950.2 times T. Okay, now we are going to find out principal stresses, because you know that in maximum shear stress theory you will need sigma 1 and sigma 2, which are the principal stresses. So principal stresses sigma 1 comma 2 is equal to sigma x plus sigma y divided by 2 plus minus under the root sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. Since these values are 0, so this term will become 0, and we will have only plus minus under the root. This term will be also 0, and we have only 9950.2 t whole square. And when this square root will cut with this square, so we will have two values, plus minus 9950.2 t. And from here we can see that one principal stress is 9950.2 times t, and another stress sigma 2 is minus 9950.2 times t. Okay, I will copy these two values because we will need, and we will move toward new page. Okay, I will paste them over here, and you can see here that both sigma 1 and sigma 2 are opposite in sign. So according to when both principal stresses are opposite in sign, so according to maximum shear stress theory, what we will take is that we will take this sigma 1 minus sigma 2 will be equal to allowable shear stress. And since we have been given factor of safety, that factor of safety is given as 1.5, so we know that factor of safety is equal to this yield strength divided by the allowable stress. So from here what we are going to do is that we will calculate this allowable stress will be equal to sigma yield divided by factor of safety. Okay, sigma yield is not given, but material is given, that is A36. So what you are going to do is that you have to go to the end of the book, and in average mechanical property table, that is in SI units, so you can see A36 is 250 megapascal. So I will show you, this is A36, so this is tensile strength, and the unit will be megapascal. So 250 megapascal. So 250 divided by 1.5 will give you allowable stress, and when you calculate it, so 250 divided by 1.5 will give you 166.67 megapascal. So this is the allowable shear stress, and according to the maximum shear stress theory, when sigma 1 and sigma 2 is opposite, so this will be the condition. And you can see that sigma 1 is 9950.2 t minus sigma 2 is minus 9950.2 t. Clear? That should be equal to allowable shear stress. Okay, so what we are going to do is that this become equal to 9950.2 t. This will be plus 9950.2 t will be equal to allowable shear stress, and that is 166.67 megapascal. So 9950.2 t plus 9950.2 t will be equal to sigma allowable, which is 166.67 megapascal, so 10 raised to power 6 pascal. Okay, so 9950.2 plus 9950.2 is actually 19900.4 t will be equal to, this is t, 166.67 into 10 raised to power 6. So from here we will get t will be equal to 166.67 into 10 raised to power 6 divided by 19900.47. So I will write 166.67 multiply by 10 power 3 multiply by 10 power 6 divide by 19900.4, and you can see that torque is equal to 837.1.69, and unit will be Newton into meter. And if you convert it into kilonewton, so it will be equal to 8.37169 kilonewton into meter. And if you round it off, so it will be 8.38 kilonewton into meter. So this is our required torque T that can be applied on this system. And this was all about this problem 610-92. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 10-87 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is if a solid shaft having diameter d is subjected to a torque T and moment M, show that by maximum shear stress theory, the maximum allowable shear stress is this one. Assume the principal stresses to be of opposite algebraic sign. So you can see this is a shaft that is subjected to torsion or torque on both sides, which are opposite, creating twisting effect, and there is a moment which is producing bending effect. So you have to prove this allowable shear stress using maximum shear stress theory. So let's start with the solution. Now you can see that due to moment, we will have bending stress, which is equal to sigma x, and this sigma x will be equal to m into c divided by I, where m is the moment, c is the radius, and I is the moment of inertia. And again, due to torsion, we will have shear stress, and that shear stress will be equal to tau of xy will be equal to T into C divided by J, where C is the radius, J is the polar moment of inertia. So what we are going to do is that we will find this C. So C will be equal to diameter is given, so C is equal to D divided by 2, and what we have is we have I, which is the moment of inertia, and for circular rod it is equal to pi by 64 d power 4. Similarly, J is the polar moment of inertia, and for circular shaft, solid shaft, it is equal to pi by 32 d power 4. Okay, now we have all these values. So what we can do is that you have to just plug it in this formula. Sigma x is equal to m, c is again d divided by 2 divided by I is pi by 64 d power 4. So you can see this 2 will cut with this, so it will be 32, and 1 d will cut with this, so we will have 32m over pi d cube. So I can write it, sigma x is 32m over pi d cube, where m is the moment, d is the diameter of this shaft. Now you can see that you have the second formula is this tau of xy is equal to T into C divided by J. So T is there, C is D divided by 2, and J is pi by 32 d power 4. And that will give you 16t over pi d cube, because 2 will get cut with this, so it will be 16, and 1d will cut with this. So from here you will get this tau of xy is 16t over pi d cube. So this is the shear stress due to torsion. Now you can see you have sigma x, which is 32m over pi d cube. Sigma y is not there, which is 0, and tau of xy is 16t over pi d cube. So we are going to find principal stresses because we are going to apply the maximum shear stress theory. So for that we will need principal stresses, and this principal stress is sigma 1 comma 2 is sigma x plus sigma y divided by 2 plus minus under the root sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. Okay, so just plug the value. Sigma 1 comma 2 is sigma x is 32m over pi d cube plus 0 divided by 2 plus minus under the root 32m over pi d cube minus 0 divided by 2 whole square plus tau of xy is 16t over pi d cube whole square. Okay, and what we will get here is that sigma 1 comma 2 will be equal to 16m over pi d cube plus minus under the root, this will also 16m over pi d cube whole square plus 16t over pi d cube whole square. Okay, now if you take, this will be equal to 16m over pi d cube plus minus, if you take 16m over pi d cube, not 16m, 16, if you look at, we have 16 over pi d cube whole square common, so it will give us m square plus t square. Okay, so making this term out of the square, so it will be 16m over pi d cube plus minus, this will be 16 over pi d cube because the square will cut with the square root, and we will left with m square plus t square. Okay, that will sigma 1 comma 2. So sigma 1 will be equal to 16m over pi d cube plus 16 over pi d cube into m square plus t square, and your sigma 2 will be equal to 16m over pi d cube minus 16 over pi d cube into m square plus t square. What we are going to do is that I do not have sufficient space, so I will copy that and we will move toward next page. Okay, so we have this equation, and we have been given that both sigma 1 and sigma 2 have opposite signs. So it means that one is positive, sigma 1 is positive value, and sigma 2 is will give you negative value. So if I plot them on this axis for Mohr circle, so x-axis will have normal stress, and on y-axis we have shear stress. So let's say this is your sigma 1 and this is your sigma 2. Both have opposite signs. So what we are going to do is that I will have the Mohr circle will be like this one. If I draw it like this, so it will be Mohr circle. The Mohr circle will be like this, and we will have this allowable shear stress or maximum shear stress. So this is maximum shear stress, or we can also say that allowable shear stress. So this allowable shear stress will be equal to which one. So you can see this is radius, this is also radius. So how will you find? If you take this whole, which is sigma 1 minus sigma 2, will give you this distance. This is sigma 1 minus sigma 2, and if you divide it by 2, so we will get this distance. So sigma 1 minus sigma 2 divided by 2 will be this one. So I can write it, sigma 1 minus sigma 2 divided by 2 is this shear stress, allowable shear stress. So if you put this allowable shear stress, sigma 1 is how much? 16 m over pi d cube plus 16 over pi d cube into m square plus t square minus, and this value is 16m over pi d cube minus 16 over pi d cube into m square plus t square divided by 2. Okay, so this will be like this. Okay, now you can see when this minus will multiply with this, so it will be minus and it will be plus. So this minus will cut with this and we will have this value as plus. So I can write it that allowable shear stress will be equal to 2 times 16 over pi d cube into m square plus t square divided by 2. And this 2 will cancel with this, so we will have allowable shear stress is 16 over pi d cube into m square plus t square, and this is the answer. And we will check that whether we have proved it or not. So I have to compare, you have to remember this. So you can see we have been asked to show that this allowable shear stress is 16 over pi d cube into m square plus t square under the root. So you can compare these two values. And this was all about this problem 10-87. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 10-89 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is the gas tank has inner diameter of 1.50 meter and wall thickness of 25 millimeter. If it is made from A36 steel and the tank is pressured to 5 megapascal, determine the factor of safety against yielding using the maximum shear stress theory, and B is maximum distortion energy theory. So you can see this is the figure, that is a tank in which there is a pressure of 5 megapascal, the inner diameter is 1.50 and the wall thickness is 25 millimeter. So let's start with the solutions. First we will check whether it is thin wall pressure vessel or not. So for that we can write, since R by T is greater than 10, so it will be thin wall pressure vessel, and we can use its formula. Okay, so R is diameter is given, since DI is given as 1.50 meter. So from here we can see that radius will be equal to DI divided by 2 is 1.50 divided by 2 is 0.75 millimeter, and thickness is given as 25 millimeter. So 25 millimeter is actually 25 divided by 1000 meter, and that will be equal to 0.025 meter. Now you have both the value, so you can just find r by t. So r by t is r is 0.75 divided by t is 0.025. So I will calculate it. 0.75 divided by 0.025, and you can see that is equal to 30. Okay, as r by t, which is 30, and that is greater than 10, so it is thin walled pressure vessel. And we know that formula for thin wall pressure vessel is we have hoop stress, which is sigma h, and that sigma h is the maximum stress. That is, we can also say this is one of the principal stresses. And then the formula is PR divided by T. And tangential or longitudinal stress, the second stress is longitudinal stress, which is represented as sigma t, and that is equal to sigma 2, which is PR divided by 2t. And we know that sigma h is greater than sigma t. Why? Because we can see that sigma hoop stress is always equal to half of tangential stress. Tangential stress is half of hoop stress. I will also show you half of hoop stress, because we know that hoop stress is PR divided by T, PR divided by T, and we have 2. So it means that you can see this value is tangential stress, PR divided by 2T. So sigma tangential is half of hoop stress. Okay, now we have this sigma 1 and sigma 2. So first we will find factor of safety using maximum shear stress theory. As we know that sigma 1 and sigma 2, they are both positive. They are having same sign, and sigma 1 is greater than sigma 2. So according to that, we have this allowable shear stress will be equal to sigma 1. Allowable, since sigma 1 is greater than sigma 2, it means that allowable normal stress will be equal to sigma 1, and that is equal to, how we will find this? We have sigma 1 is this formula, so PR divided by T. So put the value, P is how much? That is 5 megapascal, and T is 0.025 divided by T. T is 0.025. Okay, so we will calculate it. 5 multiplied by 0.025 divided by, R is 0.75. Okay, so I have to 0.75. So 5 multiplied by 0.75 divided by 0.025, and we can see that allowable stress is sigma 1, which is equal to 150 megapascal. Okay, now using maximum shear stress theory, so what we are going to do is that factor of safety will be equal to yield stress divided by allowable stress. What is the yield stress? So for A36, I have to go to the end of the book, properties table, and you can see that average mechanical property, and unit should be SI. So here you can see I will take the first one is A36, so 250 megapascal. The unit will be 250 megapascal. So I will write it. Sigma yield is 250 megapascal, and we will get factor of safety will be equal to 250 divided by allowable is 150. So 250 divided by 150 will give you 1.666, or you can say that factor of safety is equal to 1.67 using maximum shear stress theory or MSS theory. Now for part B, using maximum distortion energy theory, we know that is equal to sigma 1 square minus sigma 1 into sigma 2 plus sigma 2 square is equal to allowable square. We have sigma 1, so we will find sigma 2, and we know that sigma 2 is equal to half of sigma 1, because you can see sigma 1 is PR divided by 2 and sigma 2 is PR divided by 2T. So 150 divided by 2 will be equal to 75 megapascal. So we will put the value 150 square minus 150 into 75 plus 75 square will be equal to sigma allowable square. So we will calculate that 150 square plus 75 square minus 150 into 75 will become equal to this. So sigma allowable square is 16875, and allowable stress will be equal to under root 16875. So taking the square root of answer is 129. Sigma allowable is 129.9 megapascal. Okay, you have this, and we will find factor of safety is equal to yield stress divided by allowable stress, and that is equal to sigma yield is 250 megapascal and allowable is 129.9 megapascal. So 250 divided by 129.9 will give you 1.92. Okay, so I will write factor of safety is 1.92 using maximum distortion energy theory, or using von Mises criteria. So this was all about this problem 10-89. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.